This video reminds us of all the different theorems that we've learned for Unit 4. So first was the factor theorem, which is the relationship between the factors and the zeros of a polynomial. So x minus a is considered a factor only when a is a zero or a root of the polynomial function. So if we consider this example a cubic polynomial function, so cubic is like x cubed, so we can expect 3 zeros or roots. We have -2, 2, and 3 as our zeros. So to write these as factors, you can think about solving it. So if we have x equals -2, you could add 2 to each side to get back to the factor of x plus 2 equals 0. So kind of working backwards, we end up switching the signs. So we end up with these 3 factors. So we can use the factors to write it in factored form. Factored form is when we just write all the factors next to each other. So x plus 2, x minus 2, and x minus 3. If we wanted to get to standard form, which is when we have like ax cubed, bx squared, so on, we would need to multiply all of the factors together. This is a really good skill to practice, but it's not going to be emphasized as much in this unit. So if we look at an example of this, a quartic polynomial function, quartic is like x to the 4th power. So the degree is 4, which means we can expect it to have 4 roots. So we see here we have 1, 2, 3, 4, so that makes sense. So if we list the zeros, x equals -2, x equals -2, x equals 2, and x equals 3, the factors come from just working backwards. So we would get x plus 2, x plus 2, x minus 2, and x minus 3. So you might notice the signs and how those are changing. They're just kind of switching signs. And then to write this in factored form, we're going to want to just make it look a little more formal. F of x equals x plus 2, x plus 2, x minus 2, and x minus cubed. So this would be acceptable, but if we notice we have 2 x plus 2's. So a more correct way to write this would be to only write x plus 2 once and put a squared to show that it is a repeated root. And if we think back to what multiplicities mean, we can think about how many times these are repeated. So this 2 shows us a multiplicity of 2, 1, and 1. So if we add those up, we get 4, which was the degree we had to start with up here. So that makes sense. We end up with 4 roots.